I am going to record this session so that obviously people who aren't here, Jack being one of them today, I don't think there's anybody else, you can go back over it, okay? And they can capture what's going on with it. So matrices in R, that's where we're at today. So we have spent the last few weeks, with the exception of the last 2 weeks, yes, and I appreciate people might not be as confident and have, not been practicing over the Christmas break. I'm not expecting you to have practiced over the Christmas break, but what we're going to get to in this session is we've done some basics. Yes, we've done if statements, we've done loops. Yes, we've talked about using variables. We've started to use some functions to analyze data within R. We've talked about some of the pros of R. We've talked about some of the cons of R. But where we're starting to get to now, particularly with this session and next week's session, we start to get into actually the meaty stuff, okay? Once you can use matrices, yes, and subsequently data frames, then your analysis within R can go to that next level, and we can start to look at visualizations because we can import data sets, larger data sets, not ones that we're creating from scratch in here. So that's what the premise of today's session's about. Okay. So that's where we've been. The aim of this session I've just talked about. So we're going to identify the use of matrices and data frames. I know it talks about data frames, but they're going to come subsequently. Okay, we're going to explain what they do, and we're going to utilize them within it. And we're going to use the same basketball data that we've done in the Python unit. So those that weren't here for the Python unit, it doesn't matter. The data set that I'm using, I've borrowed from another source, okay, and it's 10 seasons worth of 10 players basketball data. Now I've changed it slightly, so it's not a direct copy of what was produced by somebody else, but it's freely available data that's out there. Now you don't have to be a basketball expert, to be able to analyze this data. Anybody interested in basketball in any way, shape, or form? Nope. Okay. Doesn't matter, because the vast majority of the data you're going to be working with, if you go into this subject further down the line, will not be stuff that ticks your boxes. Yes. I've been looking at with a colleague upstairs, missed register marks at college. Yes. Trust me, missed register marks at college do not get me up in the morning. Yes. But it's the process of actually looking for patterns and trends, looking for areas within the data that might be indicative of a problem, yes, or indicative of looking into something a little bit further. And that's your job. Yeah, that is your job as a data analyst. So we talked about vectors. I'm going to do a little bit of a recap, okay, on vectors. Now, if you're on the call, you can see my screen on there anyway, but if not, you can turn around. That's fine. A vector stores a single number or single value, yes, in R. Now, just as a reminder, what does R start counting from? 1, yes? 1. All of the programming languages start from 0, but R is different, okay? It's a statistical programming language. So a single number in R is stored inside a vector. Now, a vector can be bigger than one number. We know this. We've talked about this before. But a single number is automatically stored as a vector. And that's important you be able to understand that terminology. And this is a bit of a recap. Sequence of data elements stored in R is also known as a vector. And again, we start counting from 1. So there's nothing new there. Everybody's okay with this. Brilliant. Right. That last bit is the thing I want to highlight here. Sorry. It's because I've been talking all day. Yes, that's all. Behind a mask. It's making me very, very dry. Okay. I am going to go and get a drink of water in a minute because I did a lot of delivery in that last hour and I'm struggling. A vector is one dimension. Okay, that's key here. A vector is one dimension, basically one row of data. Okay, everybody happy with that? You're going to ask a question? Or? No. A matrix is a collection of data elements of the same type, but where there are multiple dimensions. Yes? More than one dimension. And we're not talking about Doctor Strange and, yes, other dimensions here. We're talking about there are two dimensions. Yes? There are columns and there are rows. Why is this much more useful than what we had before with a single vector? Why do you think? Could be more specific. There is a bit of an issue with this the way it is, but I'm going to get to that in a second. Charlie?
Is it because with the way that they sort of together, you can associate certain types of data together?
Yeah, that's absolutely true. But if I go back to my basketball example, yes, which we're going to use today, a vector will store, if we've got 10 seasons worth of, I don't know, salaries and scores and points and all that sort of stuff. Let's just take salaries as an example. We've got 10 seasons worth of salaries that an NBA player has had. And we've got 10 NBA players. With a vector, I can only ever look at one player's 10 season data at a time. Does that make sense? This is effectively 10 seasons for one player, one row of data. So it makes comparisons and actually any calculations or any functions I do to that data, so averages, etc., I have to do to each single player. It's inefficient. But if I've got, as we were just talking about, 10 players for 10 seasons, where the data is going to be the same, and that's the key bit here. When we get to data frames, and I really like data frames, because data frames are when you can start to pull in your CSVs and your Excel sheets, because the chances are you're going to use a data set that's not got everything in. The register one I was talking about earlier has the title of the register, the date of the register, how many minutes late it was late. Yes? There are various different types of data in there. And that can't be used as a matrix, but a data frame can be. Okay? So that's what we're getting into this morning. Now, this is not in any way due to a new film that's just been released. Okay? However, when I wrote this, it was in relation to the matrix because I couldn't think of anything else. So when we call a matrix, yes, we give it a name. Yes, now in this case, I've called it Neo, not for any other reason than I'm not very inventive. Just like we call the vector, yes, just like we call a variable, we give it a specific name. You can call that cheese and biscuits for all I care. But the structure of a matrix, when you define it, it goes in these square braces, yes, square brackets, and we have the row and we have the column number. Yeah? We have the row and the column number. Now that's if we want to call data from it. Okay, now we can call a whole column, we can call a whole row, or we can call a single data value. Does that make sense? So in order to do that, knowing the location of things, and the comma in this instance is so important, is because if we want to call a whole column, we have to go space, comma, and the column number. Yes? Same with the row, we still have a comma and then a space, because it's still a matrix. It has two dimensions, and we need to satisfy, in terms of computers, a what? If we don't tell it what the second parameter is, it's going to throw a wobbly at us. And then the last one is going to give us value 2, because it's row 2, column 1. And that's something I want you to be close attention to, because in R, 1, 2, 3, not 0, 1, 2. Yes? So that's why we get the second value, or the number 2 value here. Everybody happy with that? Okay. Okay, do I want to do that? Right, I do want to do this, and this is where I want you to have either a blank R script file available, yes, or one you're just going to add to the bottom of it. That's fine, which way you want to do it. Now we're going to look at 3 ways of creating a matrix. Yeah? So what we just showed you is what's the structure of the matrix and how you can call data from the matrix. Or a matrix, not the matrix, sorry. It's a totally different conversation. It's not a bad film, the new one. I'll be honest. It's not bad. It's not great. Has anybody seen it? Anybody seen the original?
Yeah.
2. Okay, nobody knows what I'm talking about. 3 people. Fine. I'm going to be honest. I was really frustrated this morning. Not with the Matrix. Well, technically with the Matrix. So I saw the Matrix over Christmas. Huh? Don't talk to me about Spider-Man. I haven't seen it yet. I want to see it. So over Christmas, I'm digressing. It's got nothing to do with what we're talking about. But I wanted to find, we're going to show the kids Jingle All the Way, and I've got a lot of DVDs. Okay. Now I've shoved them in a cupboard because they've progressively, as the kids have got older, they've needed more space. So it's progressively gone to one very small cupboard in the house, which is shoved full of all other stuff. So over Christmas, went to look for Jingle All the Way, and all my DVDs are piled up like that now, on top of each other, rather than like that, so you can see what's there. So I got everyone out, looked for them, got through the boxes, tried to find it. Couldn't find Jingle All the Way, but I found a number of other DVDs. I thought, I'll watch those over Christmas, including The Matrix. Very distinctive box. It's not one of the standard DVDs. It's got a little flip on the side, and right. So after we saw The Matrix, thought, right, I want to watch The Matrix. So the next night, went back into the cupboard. I know I've seen it. I've had it in my hand. Went through this entire cupboard, which has got stuff crammed in. So rather than taking the stuff out, I just climbed over everything, which made more sense until I tried to look for it. Wasn't there. I know I've seen it. Went back in. Checked through every single DVD again, and there are lots. Couldn't find it. Must have imagined it. This morning, which is nearly 3 weeks later, I saw a small pile of DVDs in a separate cupboard next to where I'd been, which I've evidently taken out and put there because I wanted to watch them later. The Matrix was on top of this pile of DVDs. I was very frustrated. Anyway, I digress. So, that's got nothing to do with what we're talking about other than me being. So the Matrix, R bind, and so row bind and column bind, that's what it means, yes? There are 3 ways we can create a matrix, okay? Now, the first one, matrix, the matrix functions bends a vector into a matrix. So it bends it into a matrix. Now, bends a vector, which is a single dimension, into a matrix. So what we have here is the structure of this. The data that we're going to pull through, yes? So this will be the vector that we're going to pull the data from, yes? The row, the number of rows that our matrix is going to have, the number of columns our matrix is going to have, yes? And dimension names, no, we're not going to give it any labels at the minute. Okay, so that's one way to do it. So the vector from which the data is, oh, it's all right, I've labeled it all up, yeah? Look at that. How the vector will be bent, yes? How we're going to pull it round, yes? So by row means we're going to put it in by row, yes? By column, we're going to put it in by column, yes? Or by row true means we're going to do it by row false, we're going to do it by column. And the names of the dimensions pulling from another vector, so we're not doing anything like that. Now, I'm going to ask you to note that down, that structure down. Remember to put it in as a comment, because we've not actually done anything yet with this. What time are we on till? 20 past 1. I can never remember. Yes. Yeah, we're definitely in that other room afterwards. Okay, so just have the structure down and any notes you want to associate with it, because I'm going to get you to start building these matrices in a short while. And whilst you're doing that, I'm just going to load up my oh, sorry. Hey, oh, snowing.
Is it? Oh no. Oh. Good luck walking back home, mate. Oh yeah, you walk back home, don't you, as well? I didn't wear my boots. I was going to wear my boots, but I was like, it's just for work day, I can't wear my boots. It's called commitment.
No, not yet.
Okay, so what does by row true and by row false actually mean? I've tried to give you some examples on the board. All right, what's the difference between the two? Yes, but what does it mean in reality? But what does it mean for the data? If I've got a data set that's got 12 values in it, yes, and I'm going to set 4 columns, 3 rows, yeah, I know that's not what the function says at the top, but that's what I've done. What's the difference in the layout of the data? Remember that the matrix function bends the data effectively. Let me just draw on the board. And I know, Jack, if you're listening to this, you can't see me writing on the board, but I'm just going to write a list of values 1 to 12. Okay, in a row. If I've got a matrix with the values 1, 2, 3, 4, oh dear, I'm going to run out of space, 6, 7, 8, 9, 10, 11, 12. That's my vector. Charlie?
Looking at the order of the numbers, it goes down by a column. 1, 2, 3, 4, 5, 6. Looking at 5 rows, there's our row.
Exactly. That's exactly what it does. So what Charlie's just said is, if I'm going to bend the data, so effectively I've changed number of rows to 3, number of columns to 4, yes? That's what I've set to start with. But what it's going to do, if it's by row equals true, it's going to divvy that data up, yes? Distribute that data by row. So it's going to go, if I've got 3 columns, 4 rows, it's going to go by row, 1, 2, I'm going to do by row first. 3, 4. Then it's going to go 5, 6, 7, 8, 9, yes? But if I say by row is false, it's going to do it by column, by definition. So it's going to go 1, 2, 3, 4, 5, 6, yes? Does that make sense? Now, why is that important? True, but we're not looking for anything. We're creating here at the minute. Understanding the structure of your data in your vector is so important. Because if I've got, go back to my original basketball thing, yes, and I said I've got data where it's 10 seasons. If I take one player as a vector and I start distributing it by row, yes, and these are different players' names, sorry, by column, I'm going to get a very different set of outputs than if I've got one player, 10 seasons. Does that make sense? So understanding, I'll go back to what I said right at the start of this unit, understanding your data at the start, what it is, what it means, dictates everything you do from this point onwards. Yeah, how you structure it. Everybody so happy so far? Good. Okay. Row bind and column bind work if you are combining vectors together. Okay? So it still creates a matrix, both still create a matrix, but what they do is they're going to bind multiple vectors together in a matrix. This one is where you've got a whole data set, a bit like what I've got there, yes? Yeah, I've got a whole data set and I want to put it into a vector. I want to create it from scratch. But if I've got individual vectors, then I want to decide whether I want to combine them by row, like that, or when I combine them by columns. And that's what rbind and cbind do. And it's simply rbind and then the parentheses and then the names of the vectors. Everybody following that? So what I'm going to do now is I'm going to share something with you in Teams. And Jack, I am talking to you because I know you're not here. But what I'm going to do is I'm going to share this set of data. Yeah? Now, these are the vectors for the different pieces of data we're going to use, yes? So in this, we've got year and players, yes, as vectors. So player 1, player 2, player 3, player 4, player 5, and then the years. And then we've got player 1 wage as a vector down to player 10, player 1 games down to player 10, player 1 minutes played, field goals attempted, and points. Okay? I'm going to share that file with you, and I'd like you to save that to your OneDrive. And we're going to build the activity throughout the session this time, yes? So I'm not going to do it as one big activity at the end because we always tend to run out of time. We're going to share that with you. Is that all right? Okay. So give me a moment. It's really snowing. There you go. So I'd like you to download that if you would, please. So it's that file. I've just put it in the Teams chat, the call of the chat. I'd like you to save it, please. And I'd like to have it open in RStudio. That's what I'd like you to do. Because we're going to, rather than do sort of disjointed activities today, we're going to embed them in with the final outcome. Have I lost anybody yet? No? Good. So again, this is not the best way of doing it. That's when data frames come in, because you'd want an Excel sheet that got all this data in, yes, or a database that's got all this data in, and you want to just pull it through. You don't really want to be doing this, but there are going to be certain situations where you do this. Yeah, you got it? Yeah, brilliant. Matt, you got it? Yeah. Alex, you got it. Christoph got it? Yeah. Brandon's got it. Yeah. Reese, you've got it. We got it? Yeah. Brilliant. Fantastic. All right. Where you put it? Yeah. Then open up in RStudio. Good. So let's talk a little bit about our bind. I'm going to show you how this works. So I'm going to try and move this across a bit. Oops. You going to let me do it? There we go. Now I've got a file, yes, I'm going to show you this in practice, where I've got the actual names of the individuals here. Do we remember what the C is? The C function. We used it for creating vectors. We've got it there. In fact, I've got it on my presentation as well. What's this C function here? Well, there are multiple numbers there that are being brought together in a vector. There's one thing. That's the clue. They're being brought together. What word beginning with C brings things? Pardon? Concatenate could be. I call it combine. It might be concatenate, but I thought it was combine. But you combine the data together, yes, into one vector. I'm going to double check that now because I'm not sure. And then row bind says bind by row. Yes, so what you should get is this. 1, 4, 7, 10, 2, 5, 8, 11, 3, 6, 9, 12. Make sense? So it keeps the structure of the vector itself, saying that belongs to one version, belongs to another version, belongs to another version, which is how we understand normal tables to work. Yeah? I'm less keen on column bind. Yes? I'm less keen on that because I don't see the purpose of it really, unless you're collecting individual sequences of data about a topic. Yes, if you're using sensor data for week 1, week 2, week 3, week 4, etc. Question, what's the difference between the matrix function, and I'm going to dip back, and C-bind and R-bind? How many more parameters do we need to set in matrix than we do in row bind, column bind? Particularly focusing on the red ones. You don't. Yeah, you have to set the way it's structured in matrix. Yep, you're absolutely right, Charlie. But in these, what's dictating the rows and columns? The vectors themselves, the amount of data. So the number of vectors dictates the columns. Sorry, the rows. Yes, my apologies. In R-bind, the number of vectors dictates the rows, but the columns is dictated by the number of elements in the vector. Okay? Now, what I will say here is that if you're going to combine them, they need to be the vectors need to be of the same type of data and the same amount of data. So, say again? It won't fill it automatically. It'll throw wobbly. Yeah? Now, when we were combining multiplying vectors together, yes, it did. Yeah, that's when we had that extra bit to it. But what this will say is that you've not got them of the same type. Remember, a matrix is based on the same type of data. But if you've got a vector of 3 and a vector of 4, it won't fill it, as far as I'm aware. Yeah? And then this one, again, the structure changes based on whether we're doing column bind or row bind. Okay. So this is what we're going to do. So I've now given you, it's like I preempted this, or I may have taught it before. You will now utilize one of the methods relating to the creation of matrices to create the following matrices. That's a really bad sentence. But what I want you to do in a fresh R script file, which you're going to call basketball data, etc., I've just given you a huge set of data. Yes? A huge number of vectors. I'm not asking you to create the vectors from scratch. In fact, you may want to do this beneath those vectors on that script file you just saved. Sorry. I want you to create a matrix of field goals, games, and salary. Now, you're going to decide whether you're going to use the matrix function, the row bind function, or the column bind function. So I want you to create 3 matrices, with those in it. And I'm just going to go and get a drink of water before my throat gives up. And when I say my throat gives up, I don't mean that I've got like a cough or any other symptoms. It's purely because I've been talking behind this mask all day. Any questions about what I'm asking you to do? No? Okay. What I am going to do is I'm going to stop the recording there while you guys do that activity, so there's not just a load of silence. So Jack, there will be a second element to this.